Welcome to Lecture 3.1. We'll be working with paired data and graphing ordered pairs. So we're beginning Chapter 3, which is working with linear equations and inequalities in two variables. And in earlier videos, we worked through linear equations and inequalities with one variable, but now we're going to step it up a notch and do two variables. So let's handle some of our information that we need to know when it comes to graphing. The parts of the graph are a horizontal axis that lays on the ground. Think of that, horizontal. And a vertical, it stands up, vertical axis. So we have different types of charts, and we've chatted about a couple of them in the past, but let's go through and talk about, we have a column chart, and the paired data would be in this area. So anything in the graphing area is our data set. A scatter plot, which just looks like a whole bunch of dots, and the line graph, which is, in essence, a scatter plot with the dots connected. Let's think about some of the data that we've had in the past, like sequences. So let's take a sequence of, let's say, odd numbers. And with the odd numbers, let's write them as an ordered pair. And you might be saying, well, how do I do that considering I only have one number? 1, 3, 5, 7. Well, that's only one number. How do I write it as an ordered pair? Well, let's say each number is going to be in a position. So the first number will be the first position, second number will be the second position, third number will be the third position. So now I can write them as a set of numbers or a set of ordered pairs. In the first position, I'll have a 1. In the second position, I'll have a 3. In the third position, 5, fourth, 7, and 5th, 9th, and so on. I could continue this series. Think about what it would be if we took each number, 1, 2, 3, 4, 5, and squared them. Could I set up a similar situation in that sense? I could. Again, positions would be 1, 2, 3, 4, 5, but this time the value would be 1 times 1 is 1. The second position is 2 times 2, which is 4. The third position, which is 3 times 3, which is 9. Fourth, 4 times 4 is 16. And fifth position, 25, 5 times 5. So we're starting off thinking about pairs of data now. And in terms of when we're graphing, we have two numbers. They are a pair. One is the x-coordinate, and the other is the y-coordinate. So what is it? It's a pair of numbers enclosed in parentheses and separated by comma, and it's called an ordered pair. The first number in the pair is called the x-coordinate, and the second number in the pair is the y-coordinate. We call it an ordered pair because we never change the order. The x always comes first, and then the y-coordinate. We also have a graph representation or a picture representation of how we're going to put this data on a piece of paper, a two-dimensional object, and it's the Cartesian plane. It is the rectangular coordinate system, the Cartesian plane. And the cool thing about this is the Cartesian plane wasn't made up by a mathematician, not at all. It was actually made up by a philosopher by the name of René Descartes, long time ago, in the late 1500s, early 1600s. And he was a French philosopher, and he came up with that good old phrase of, I think, therefore I am. Now, I'm not a philosopher, I'm a mathematician, so how does this relate to math? Back in the good old days, we had two systems of math, and neither one shall the twain meet, or however that saying goes. And it was algebra, which dealt with x's and y's and z's and letters, and geometry, which handled shapes. And the two groups, the algebra group and the geometry group, never really talked to one another, or they really didn't think that their two math expertises combined. Well, Rene Descartes thought differently, and he came up with this coordinate system. It is the Cartesian plane, what we call it now, or the rectangular coordinate system. And it bridges the gap between algebra and geometry. So I can take an algebraic equation and I can graph it. So I can take an x and I can plot it either on the left or on the right, and then I can take a y, and instead of just having two horizontal rows, that doesn't really give us much to look at. We've decided that the y is the y-axis. Any of the y values, it goes up and down. So it is divided up into 4 quadrants. The first quadrant, the upper rightmost quadrant, is all the positive x's and the positive y's. So if you think of this starting point in the dead middle as 0, if I go to the right, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, you've seen a number line already. And if we go to the left, it goes -1, -2, -3, -4. Well, think of the same thing for a y, but now it's, instead of laying flat, we've turned it up like this. So the y, again, will start at 0, and it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up positively, and then comes down negatively, -1, -2, -3, -4, -5. And when we start graphing these things, we're going to go over some, up some, over some, maybe down some, maybe to the left and then up, maybe to the left and right. Maybe we'll just stay on each of the lines. So if you think about breaking up these quadrants, there are all the positive x's and all the positive y's. So in this area, quadrant 1, both x is positive and y is positive. Let's move over to quadrant 2. And I know it feels like we're counting backwards, like counterclockwise, but we do. It is counterclockwise. Quadrant 2. Now the x's are negative and the y's are positive. So in this square block, in this quadrant, quadrant 2, the x's are negative and the y's are always positive. Let's move down to quadrant 3. Remember, x's are negative already, but the y's are negative. So in the quadrant, the lower left-hand quadrant, quadrant 3, both x is negative and y is negative. And finally, we get to quadrant 4. The x's are back to being positives, and the y's are negative. Therefore, quadrant 4 is positive x's and negative y's. Remember, this is an ordered pair. We always write x first, and then y. So just to be official, an ordered pair is first the x-coordinate and then the y-coordinate. The x-coordinate is the horizontal distance from the origin. So it's either going left or right. So left or right. Okay. The y-coordinate is the vertical distance from the origin. So we're either going up or down a certain distance, and that's going to be the y-coordinate. And how we get off to the side is we have so many to the left and right and so many up and down, and that will get us off of the lines. If we only had 2 horizontal lines, the x and the y, we'd never move off those lines, and it's not 2 dimensions. 2 dimension is some up and some left and right. How we write it is parenthesis x comma y parenthesis, the intersection of the x-coordinate and the y-coordinate. Once we start plotting a few points, this is going to make a little bit more sense, so just hang in there. So let's move on to graphing. I've written down 4 ordered pairs. The ordered pairs are 3, 4, 3, -4, -3, 4, and -3, -4. So let's plot the ordered pair of 3, 4. That means 3 in the positive x direction and 4 in the positive y direction. So here's my graph. I start at 0 and I move 4, 1, 2, 3, 4 to the x, 3 to the x, 1, 2, 3, and then I move up 4, and there's my point, 3, 4. Let's take the next value of 3, negative 4. Again, I start at the origin, and 3 is my x, so I move to the right 3 because that's in the positive direction. 1, 2, 3, and then negative 4. So it is in the negative 4 direction, which is down. 1, 2, 3, 4, and I plot my point. You do want to label your points too, so there's no confusing which point is which point. The third point is negative 3, 4. This time I always start at the origin 0, but I have a negative 3, so I move to the left 1, 2, 3, and then I move up positive 4. 1, 2, 3, 4, and my point is negative 3, 4. My last point is negative 3, negative 4. Again, starting at the origin, I move to the left 3 spots, 1, 2, 3, I'm sitting at negative 3, and then I move negative 4, which would be down 4, 1, 2, 3, 4, and I plot the fourth plot. Pardon me, plot the fourth point. Alright, so let's try a couple of points ourselves without it previously being done for us. Let's take the first pair of negative 1 and 3. So I always start at the origin. My first coordinate is always my x, and that determines left and right. So I go negative 1. Negative is to the left direction, so I had negative 1. And then 3. 3 is positive, so I go up. 1, 2, 3. I plot my point, and I label it. Let's try the next point. 2, 5. Again, starting at the origin, and my x is positive, so I move to the left, 1, 2. Y equals 5, so I move up, 1, 2, 3, 4, 5. And I plot my point of 2, 5. My next point is 0, 0, so I start at my origin, and my x is 0, so I don't move left or right any, and my y is 0. And I don't move up or down any, so I'm actually at the origin, which is 0, 0. Right? 0, negative 3, next point. So my x, I start at 0, and my x is 0, so I don't move any to the left or right. But my y is negative 3, so I move down, 1, 2, 3. Again, I'm not lefting or righting any. So my final position is 0, negative 3. My last point is 4, 0. Starting at the origin, I move to the positive direction 4. 1, 2, 3, 4. But y is 0, so I don't move up or down any. So that is my point. 4, 0. So that's the end of part 1 of this lecture. Stay tuned for part 2. Until then, be seeing you.